Hello guys, I will be doing the QST video for the chemistry EMS for tomorrow. I'm not supposed to be doing this video, but due to some irresponsibilities, the job is mine now. Anything that is an ion means it's charged. So if it is positive or negative, for example, positive and negative, it means it's an ion. An atom carrying a charge. Yes, it is an ion because it has a charge. A molecule carrying a charge, yes, it is an ion because it has a charge. Now let's see why these two are not ions. A neutral compound, it's neutral, it does not have a charge. This means that it's not an ion. And an electron is negative, okay, it does have a charge. But there is one thing, it's it's a subatomic particle. Subatomic particles cannot be ions because ions are made out of subatomic particles, in which one subatomic particle has a greater amount than the other. Okay, so it's either a proton has more, it's either an atom has more protons or more electrons. Okay, so it cannot be an electron itself, it has to be an atom or a molecule or a compound, not a subatomic particle like an electron or a proton. Now for this one, a saturated solution is just memorizing when there's max solute in a given solvent at a certain temperature. So basically, when we have the maximum of X in given Y at certain temperature. Okay? Max of X in given Y at certain temperature. Okay? Precipitation is the process which involves the formation or the making of a solid component from an aqueous solution reaction. This is to memorize. Now, when they said that when temperature is 0 and pressure is 1 atmosphere, it's gonna be STP. And at STP, the volume of one mole of a gas is 22.4 decimeter cubed. Meanwhile, at RTP, it's 24. Now, for this one, they want us to write it at 1 sig fig. They wrote here 1 sig fig. So the volume will be at STP. But let's say that we have a volume. Okay, this is usually it's not usually, it's always at gases. Let's say we have it at liquid and solid. Here they told us to write a 0 because it's negligible. Solids and liquids have a negligible volume. Okay. Now, so here they wrote for us the multiplication factor. So there's no need to do the big calculations. We can just copy the amount of moles, since the volume at S/RTP is equal to the moles times the value, right? Using cross multiplication, because like, let's say we're using STP, which we are using STP. One is gonna be 22.4, then X is gonna be Y. Okay, so let's just copy down the moles to 7, 4, and 6. But there's one wrong thing. Why did we not write a 6 here? The reason is because all of these are gases, okay? But this one is a liquid, so it has negligible volume. So it's not gonna be a 6. That's completely wrong. It's gonna be 0. Because they told us here to write 0. Maybe they might ask us to write 999, but we don't know. Okay, here they forgot to write us the multiplication factor, which is supposed to be this part, but usually in the exam they're gonna provide it for you. If they were not to provide it for you, then it would be logical to just write the amount of moles, since they asked the answer to be in 1 sig fig. So basically, since it's a solid, it would have a negligible volume, and the gas, you just copy down the amount of moles. Okay, you copy it down, and here number 2 you copy it down. Okay, this is an exothermic reaction, so it will release energy. Exothermic means to release energy, to give off energy. So energy will be in the product side, which is in this side. And Here they said that when 1 mole of H2, if there's 1 mole, it will release 284 kilojoules. Here there is two moles of H2. So we just multiply 2 by 284 and we get 568. Sublimation, remember dry ice moves from solid carbon dioxide to gas carbon dioxide, directly going from solid to liquid state. So from not from liquid, from solid to gases. Okay, remember, it does not pass to the liquid state. So from solid to gas. My bad for that mistake. Okay, here what they did for us, they did not include us this part, okay? We just had to formulate it ourselves using this given. We just have, they said the dissolution, so when this solid splits up into ions, remember ions, okay, it means like it's like in an aqueous solution, so always remember aqueous solution, okay? So break this up, it will be Na plus or minus, it's plus because it's a solid, you have to memorize this. Na plus, is it solid, liquid, or gas? It's gonna be neither three of them. It's gonna be aqueous, as I said, plus Cl minus aqueous. Remember, always aqueous, 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 aqueous. Aqueous, it means it's dissolved in water. Now it's gonna be the charge. The charges you have to memorize them. And this is logical. We've learned this for the past many years. It's Na plus and Cl minus. And remember, it's aqueous. So this is the answer. Okay, for this one, just copy down the number of moles. So they said they asked for molecules, and in this case, we can say that molecules is like like we can enact the molecule to be the same as a mole. Okay. So how much do we have here? We have 1 because the coefficient, there's no coefficient here, so it can just be 1. Here there's 3 hydrogen, okay, and 2 ammonia. 2 ammonia or ammonium, I'm not sure. It's 2 of it. Okay, here it's just like balance it. Like there's nothing to balance though. Like there's 1 silver and there's 1 NO3. Remember, NO3 is it's a polyatomic compound, so it's together. It's a polyatomic molecule. Okay, so it's gonna be together. So there's 1 NO3 and there's 1 Ag, 1 silver. So it's 1 to 1 to 1. A solution in which a solvent is water is aqueous. This is to be memorized. Molar concentration is also to be memorized. It's easy though. It's the number of moles in 1 liter. X moles in 1 liter. Okay, now for this one. We learned the rule C is equal to N over V, right? And then we also learned the other, we derived that N is equal to CV, right? We can also derive something else. Here they're asking for the mass. Why? How do I know they're asking for the mass if they do not provide it for us? They said weigh. Weigh, we can have a hint of weight, but we can also have a hint of mass, right? So basically, if they gave us the molecular masses, okay, and if they gave us if they asked us for the mass, we can substitute moles by m over m. Didn't we learn that n is equal to m over m? Just substitute it. And then we can just multiply m here. Let's multiply it here. It crosses out and multiply it here. It crosses out. So m is equal to c times CVN. Okay? So we derived this rule. We need to find mass. Did they give us concentration? Yes, concentration is 1 mole, 1 molar, times 1 liter, times what is the molar mass? We calculate it here. It's NaCl, so it's 1 to 1. So 23 plus 35.5 is gonna be 58.5 is equal to the mass. And we simplify this, it's gonna be 58.5 because this is equal to 58.5, right? So the mass is equal to 58.5. So we weigh 58.5 grams of pure NaCl. Now, our teacher taught us that whenever we're trying to test the solution of an ion, of an ionic compound, we always put little water. If it's aqueous, yeah, it is gonna be aqueous because we're testing the solution, so it's gonna be aqueous. We don't, and let's say it's gonna be 2 liters. We're trying to put 2 liters, a specific amount of the aqueous solution, let's say 0.5 molar of the aqueous solution in the 2 liter flask. We don't always put it to the brim, so we don't always fill it 2 liters and then we put the aqueous solution. It's always better to keep it a bit. Let's say we do 0.5 liter, okay, or 500 milli, okay. We always fill it a bit, 500 millimeters, and we put 0.5 molar in the solution, and then we wait for it to dissolve, and then we add the remaining liters of water. This is the reason behind this, is so we can get the exact amount of volume, because if we put all the water first and then we put the ionic compound, the volume is gonna be different, because the ions there's gonna be a different arrangement at the microscopic level. So if this sounded a bit confusing to you, just memorize the fact that we don't always fill everything to the brim. We always add a bit of the solvent, okay, which is here it's water because it's aqueous. We add a bit of water, okay, and then we add the solute a bit, if that makes it clear. Okay, so just firstly add a bit of water and then add the ionic compound and then fill it to the brim, if that sounds confusing. Okay, just memorize it this way. You add salt to about 250. The only volumes they gave you is 250 and 1000. 1000 milliliter is 1 liter. It's the same thing. Didn't we just say that we should not fill it to the brim? No, we just said that we should not fill it to the brim. We should always fill it a bit. So we use 250. And a 1 liter volumetric flask, since they're asking for the volume, so it's better to use a volumetric flask. And then we mix it until most of the salt is dissolved. Okay, this is what we're waiting for. We're waiting for the salt to dissolve, and then we add more water to make exactly 1 liter. Not almost 1 liter. No, we want it exactly, not approximately, exactly 1 liter of NaCl solution, aqueous. Okay, so always just memorize it. We should never put it to the brim. Just wait, put a bit of the solvent and then add the solute and then add the remaining solvent. Here it said that 2 liters of 1 molar NaCl put in a flask, 400 milliliter of the solution is poured into a flask of repeated concentration. Okay, no matter the amount of solute you put, it doesn't matter the concentration, the volume of the solvent is always gonna be the same. Okay, that has nothing to do with the solvent. The solute is gonna change, that's fine. Okay, but what does the concentration is gonna change? The concentration is not gonna change. What does that have to do with the other one? Just memorize the concentration is gonna stay the same unless something else they tweaked it. If they did not change anything, then you should not worry about the concentration changing. Thus, the concentration will remain constant from 1 molar to 1 molar. Again, just memorize it this way if it doesn't sound that clear. So, concentration will not change because it has nothing to do with the givens. So, concentration will remain constant under these given conditions. They want the correct definition for a solubility of a solid at a given temperature. Solubility of a solid. What did we say? 1 molar solution? No, what does that have to do? Mass and density? Mass and density are out of the scope of our lesson. not out of the scope, but like they have nothing to do. We can just instantly eliminate density and minimum mass. What does that have to do? Now these two ones are the ones that you may narrow them down using the point of elimination, a process of elimination, I mean. It's definitely not going to be 1 molar of solution. Just memorize it's the concentration of saturated solution. What did we say was a saturated solution? What was the meaning of saturated? The meaning of a saturated solution is a solution in which it has the maximum solute in given solvent at a constant temperature. What did they say? At a temperature T at a temperature T degrees Celsius. So that means it's gonna still say the same temperature. So we have this part that's correct. So this part is correct. Then we have solubility. It's max solute in given solvent. So just memorize it's the same thing as saying a saturated solution. Okay, these two mean the same exact thing. They're just trying to complicate your life. These two things mean the exact same thing. Now this one, CaCl2. Firstly, what is CaCl2? What can you notice? It's gonna be Ca2 plus aqueous plus Cl minus aqueous will give CaCl2 solid. Or it's the other way around. Since it dissolves in water, it's gonna be CaCl2 solid is gonna give this. Okay. It dissolves in water, and we usually learn the properties of an ionic compound. What is the properties of ionic? Properties of ionic, it conducts. Okay, these are one of its properties. So it does conduct electricity and heat. Okay, memorize this. Ionic compounds conduct electricity and heat only if and only if they dissolve in water. Now sugar. What is sugar? It's covalent. Sugar, when it dissolves in water, can it conduct electricity? Are these one of the properties of a covalent compound? No, it's not. Only its property of ionic. Okay, so sugar does not conduct electricity or heat. This is because unlike sugar, when CaCl2, which is an ionic compound, when it dissolves in water, it forms charged ions that allow the electric current to flow. What did we say? Look at these ions. Can you see these charged ions here? Can you see these charges? Tell me yes or no. Yes, you can see the charges. That means that these charges allow the electric current to flow. Long story short, ionic compounds, when dissolved in water, they can conduct electricity. Here we just need to balance how much Na we have here. We have 2 Na, and A is 2. How much CO3 do we have here? CO3 is 1. Remember, CO3 is a polyatomic ion. Now, how much Na do we have here? We have 1, and CO3, we have 1. Just multiply by 2 here, so it becomes 2 Na. Okay. Now, when we have ionic equations, we have something called overall non-ionic, overall ionic, and net ionic. Overall non-ionic are the normal equations we're used to having. We're used to have. Now, overall ionic is when you take each of the molecules that you have, or each of the compounds that you have, and you break them into the respective ions. For example, we have NaCl, or this is too complicated, without an example. Okay, we have overall ionic, each of the compounds, and we split them up into each of the respective ions. So we break everything up and we put it and you put each element on its own, of course, except for the polyatomic ions. Then we have net ionic. Net ionic is when we cross out and we keep in. What do we cross out? We cross out the ones that are irrelevant and we're keeping the ones that are relevant. You can guess that. Relevant, okay? What do I mean by irrelevant and relevant? Irrelevant, that means that they are ions that form to make a solid or a liquid. And irrelevant are the ones that are the ions that form, are the aqueous ions that still form aqueous ions, in which they do not form a compound, they stay split up. Okay? So these irrelevant ions are called spectator ions, and these relevant ions are called predominant. Okay? So that means that if they're relevant, that means they participate in the reaction. Spectator, they do not participate and they still stay aqueous. So if they participate, they're called predominant species of ions. A fractionating column is this tube right here. You have to memorize it. It's just this tube. Okay? And they're asking the definition of a fractionating column. It is a long vertical tube. As you can see, it's long and vertical, and it has obstacles that is cooled by air. Okay? As you can see, we see the particles here, and they have like obstacles. So there are like these things here. Okay? And it's cooled by air. We have here air, and it gets cooled. Okay, just cooled by air. Just memorize this. We can apply these rules here. So basically they want the molar concentration of, okay, molar concentration C is equal to N over V. The mass is gonna be sorry, not the mass, the moles is gonna be 0.5 and the volume is 1. 0.5 divided by 1 is 0.5, but they want 2 sig, so it becomes 0.50. They want moles of sodium bicarbonate, which is let's first of all, let's do sodium bicarbonate. We have Na and CO3. And what's the charge of Na? It's Na plus, and CO3 is CO3 2 minus. Crisscross applesauce. That's so cringy, but crisscross. You move the 2 down here, and you move the positive down here, so it becomes, you move not the positive, the 1 I mean. So the formula is Na2CO3. Oh, I just realized they put it here. I didn't see that. Okay, but we just made it ourselves. So they want the moles. N is equal to CV. C is gonna be 0.5. They said here the concentration, and the volume is gonna be 0.1. 0.5 times 0.1 on the calculator is gonna be 0.05, but they said 2 sig fig, so 0.050. Now they ask the volume. If N is equal to CV, then you divide by C on both sides, and you're left with V is equal to N over C. The mass is gonna, why do I keep on saying mass? The moles is gonna be 0.1, and the concentration is 0.2, and 0.1 divided by 0.2 is 0.50. Remember 2 sig fig. And now here they're asking for the mass of it. We know that moles is equal to mass over molar mass, so if we use N is equal to CV, we can deduce that mass over molar mass is equal to concentration times volume, and we can say, sorry, we have we have this here, Na2CO3. Let's just move the molar mass to the other side, so we multiply by molar mass on both sides, and we have it here. Now we can just find the concentration, which is 0.1 molar, times the volume. This is in centimeter cube. We wanted decimeter cube. So to centimeter cube to decimeter cube, we get that this is 0.1 decimeter cubed. So 0.1 times 0.1 times the molar mass. The molar of Na, it's 23. And the one of CO3 is gonna be... oh, they wrote it for here. Oh, sorry, I didn't notice. Here we have it here. So let's do Na2, which is 23. Let me just 23 plus 23 plus carbon is 12 plus oxygen, which is 16 times 3. Okay. Now we do 23 plus 20. We get 46 plus 12 plus 48. We add these up and we get 106. So just add all of their molar masses. So 106, 0.1 times 0.1 times 106, we get it 1.06 grams. Okay, here they just want us to balance it for some, it's just like, it's gonna be like 3Cl here. Wait, yeah, it's just gonna be 3Cl because Fe, there's like, let's just draw the table if you want, if someone doesn't understand it yet. We have Fe, which is 1, and Cl, which is 3, and here we have Fe1 and Cl is 1, so we just multiply by 3, so we add the 3 here. This next question is prerequisite question. We know that moles is equal to mass over molar mass. So 0.109 divided by 65.4, because it's mass over molar mass, which is equal to the moles, because here it's given the stuff. And we get that it's 0.0016667, but if we round it, we just get 0.00167. And we have the number of moles of zinc. They want it in scientific notation, so it becomes 1, 2, 3, and it's 1.67 times 10 to the power of negative 3 moles. And they want it to 3 sig fig, so this is a good amount. And then in part B, they're asking for the number of moles of hydrogen. And since zinc here, it's 1-to-1 with hydrogen, because look, there's one zinc here and there's one hydrogen here. So if zinc is 1.67 times 10 to the power of negative 3, hydrogen is also gonna be 1.67 times 10 to the power of negative 3. Okay, so they're both gonna be the same. And then they're asking for the volume of hydrogen at RTP conditions in centimeter cube, not decimeter. So if 1 is 24, then 1.67 times 10 to the power of negative 3 is gonna be x, and then if we cross multiply, we get that x is equal to 0.004, actually 0.04. You're gonna get a number, but this number is gonna be in decimeter cubed. What's the problem? You want it in centimeter cube. So what you do in the calculator, you put 1.67 times 10 to the power of negative 3 times 24 times 1000, right? Because to go from decimeter to centimeter cubed, you multiply by 1000 and you will get that the answer is 40 centimeter cubed. And this is the answer. Sorry for taking too much time and over explaining, but this is for your own good. Exothermic, it means it releases energy. We can see that, look, the energy, it's given out. Okay, so we give out energy. So 2H2 plus O2 will give out 284 kilojoules with 2H2O. Okay, look at this, it's decreasing the energy of the solution, but that means it's increasing the energy of the surroundings. So that means that energy is being released. Look how it's decreasing, it's being released, given out. Okay, so it's gonna be exothermic. And okay, so when 1 mole of water is produced, 284 is gonna be released because it's exothermic. And here we have that, here they said that when 1 mole of water gives 284, what will happen if it's 0.5? You just do 0.5 times 284 and you will get 142. Okay, it's gonna be the same thing. Okay, so when 1 gives out 284, 0.5 is gonna give 142, just half of it. And then the last and final question, the volume of one gas is equal to the volume of the whole thing, since volume is shared. Okay, volume is gonna be the same in all cases, so the volume of one gas is the same thing as the volume of the whole vessel. I hope everything's understood. Please reach out to me, and sorry if the video is very long. I'm just doing this for your own good, and good luck in the exam tomorrow. Thank you.